Okay, so let's continue solving this problem. This is the second hour of Physics 1C for October 1st. So we already figured out that we can really only use these three equations right here. So let's go ahead and do that. The one thing I notice is that both of these equations have an I2 in them. So what we could do is we can kind of solve each equation for I2. Or, I'm sorry, we can solve each equation for the other variable, like in this case I3, and then we could kind of plug the value of I3 in here, and then the value of I1, we can plug that one in here. So let's do that. For this equation here, we would get something like negative 2 I3 would be equal to 10 volts minus 6 I2. Tell me very quickly if you guys see that I make an algebra mistake here, because if I drop a negative sign somewhere, it's definitely going to be hard to find it later. We want to solve for I3, so this tells us that I3 is equal to 10 volts minus 6 I2, and then that's divided by negative 2. That's one equation we can use. Let's use green or something. The next one would be this equation. We want to solve this equation for I1 now. So we could write negative 4I1 is equal to, we're going to move everything else to the right-hand side. 10 plus 14 is 24 volts. It'll be negative when we move it over here. And then we have 6I2, that'll be positive when we move it over here. Divide the 4 through here, the negative 4, you get something like I1 is equal to negative 24 divided by negative 4 would be 6. And it's technically volts divided by ohms, so this is actually going to be amps now. I don't need to do that, do I? Okay. And then 6 divided by negative 4, I believe that's 3.5, so, or 3 over 2, so it's like 1.5 times I2. So those are our two equations, this one and this one. And we want to plug them into here. So let's do that. So this says I2 plus I3 is equal to I1, right? So let's write I2 we're going to leave as I2. I3 we're going to plug in this. So plus, let's simplify, well, we'll wait to simplify it. So 10 volts minus 6 I2. So that's, we plugged in I3, and then we'll plug in negative I1. So this will be negative 6 amps minus 1.5 I2. And all of that should be equal to 0. And then we just need to kind of group the I2s together. So we have I2. Let's simplify this out. So 10 over negative 2 would be negative 5. And again, that's going to end up being in amps because the 2 is technically in ohms. So negative 5 amps, and then negative 6 divided by negative 2 would be plus 3 I2. Then we have minus 6 amps. Minus for this will give us plus 1.5. Okay, negative 5, negative 6. There's this 11 showing up here now, so let's see. We're going to have, let's see, I2 plus 3 I2. That's 4 I2, plus this one would be 5.5 I2. Let's just check to make sure. This was negative over negative. Negative, negatives, they're both positive, yep. This should be equal to negative 5 plus negative 6 is 11. So this is now negative, or positive 11 when we move it to the right-hand side. And 11 divided by 5.5, we get I2, whatever that is, like a fifth? Is that 0.2? Can y'all help me out with that? Is that right? Ah, 11 divided by 5.5, so it's like 110 divided by, yeah, you're right, you're right. Just 2 amps. All right. Did anyone do this that got the same answer over the break? It's okay if you didn't, I'm just curious. You did? Okay, cool. Now that we know what I2 is, we can very easily figure out what I3 is, because if I2 is 2, then it's going to be, so 10 volts minus 6 times 2 amps. Remember that these have units of ohms here. I just kind of left them out. Divided by negative 2 ohms. And we get, so 10 minus 8, 8 divided by 2, but it's negative. Is it negative 4? God, it feels like I did that wrong. 10 minus 8 is 2. Oh my god, I'm so bad. It's 1 amp. Negative 1 amp. 10 minus 8 is 2 divided by 2. So this would be what I3 is. Notice that the answer is negative, which means that if you were to place an ammeter in here... Oh my god. It's 10 minus 12. Yeah, it's positive amp, close to 1 amp. Okay. Like, talking out algebra doesn't work out very well. Ever. Okay, 1 amp, positive 1 amp. Okay, and then for I1 right here, let's just erase that arrow. For I1, you get 6 amps. 6 amps minus 1.5 multiplied by I2, which was 2. So you get that I1 is, okay, let's be careful here. 2 times 1.5 is 3. 6 minus 3 is 3. I almost said 2 for some reason. And then we can go back and we can check. We originally stated that if we did I2 plus I3 minus I1, you should get 0. So I3 is 1, plus I2 is 2, minus 3, you get 0. So this, we fixed this one. So those are our answers. We could usually, like if this was an exam or something, I'd have you all write them like a column like this, that I1 is 3 amps, I2 is 2 amps, I3 is 1 amp. Turns out that the directions that I chose in my problem up here were correct, that the current in the top one does go left, the current here goes right, and the current there goes right, according to the fact that these are all positive. Okay, does anyone have any questions? Did I accidentally just start that, really? Sorry about that. Any questions at all? Okay, now, do you guys want to do it the matrix way? Want to see how to do it the matrix way? Okay. So for this, what I'm going to do is I'm just going to grab our equations, and we're going to rewrite them. So we'll do it a little bit lower here. So this was one of our loop equations. Seriously, why does it do that? I just want to click. There we go. Okay, that's one equation. This is another equation. And this is another equation. Each one of these we're going to rewrite in a slightly different form. So for all of them, we're going to put the voltages on the right-hand side of the equation, and we're going to organize them so that the i's appear in order, okay? So for this equation right here, is Earth really off right now? That's great. I didn't know that. I like Earth. Earth's really fun. Okay, we're going to order them. So we have 4I1, but it's negative, right? So I'm going to write this as negative 4 times I1. Next, I'll write I2. So it'll be negative 6 times I2. We don't have an I3 here, but I'm going to put a placeholder for I3 and say it's 0 times I3. Because obviously 0 times I3 is equal to 0. We didn't change the equation by doing that. And then we'll move all of our voltages to the right-hand side. So we have negative 24 volts right here. Okay, that's our first equation. Our second equation right here, there's no I1 term. So we're going to have 0 times I1, and then 6 times I2, and then negative 2 times I3, and then the negative 10 goes to the right-hand side and becomes 10. This one's really simple. We just need to reorder them, right? Negative I1 plus I2 plus I3, not 3, I1 I3 is equal to 0. Now that we have our three equations, we're going to kind of stack them up like this. We're just going to take this one, and we're going to stack it down here. Come on, computer. Do something. Here we go. Just let me click. That's all I ask. Okay, we're going to stack them on top of each other. Copy, paste. We're just going to do it like that, because that just seems a lot more consistent. We're going to take all of these. And we're going to construct a matrix out of this right here. So the way that we're going to construct our matrix is that the coefficients are going to become the coefficients for I1, I2, I3, and on the right-hand side you're going to have your EMFs. And we're just going to make a matrix. So the coefficients of I1 are -1. The coefficient of I2 here is +1. The coefficient of I3 right here, I pulled over an extra little piece here by accident. For I3, the coefficient is 1, and it's equal to 0, so the equal sign is like what shows up on the right-hand side. For the second line, you have 0, -6, -2, +10, and then -4, -6, 0, and -24. Did I mess one up? I was sure. Yeah, this is +6 right here. Thank you. Let's check everything. So -1, 1, 0, 0, 6, -2, +10, -4, -6, 0, -4, -24. So that's our equation. Now, how you actually do the next part is really going to depend on like what you have. It looked like somebody posted something for how you do it with a Casio calculator. Can I get like an online like TI-84 emulator or something? Is that something I can freely find without downloading anything? So I want to show you like what buttons you push on your calculator. This kind of looks the same. I don't know. So instead what I'm going to do is, what we're going to be doing here is we're going to be doing reduced row echelon form. Okay? And reduced row echelon form. Here we go. Like this website, RREF calculator. Okay? So all we need to tell it here is that we have one more, it's a 3x4 matrix. So 3x4, and within this matrix then what we'll do is we'll plug our matrix right here. All of this can be done on a TI, and I'll show you the steps on a TI. I wish I could just, oh, this is not being, I need to get this to go like right to the edge. There we go. So we're just going to plug these in here. So -1, 1, 1, 0. Oops, not done yet. 0, 6, 6. -2, 10. -4, -6, 0, -24. And then we're going to do RREF calculator. That didn't work out. Oh, it did. There's our answers right there. So when we put this into the calculator, what it said was, what it spit out was, this is going to spit out your answer, and it's always going to have, if it worked out right, it's going to be like a diagonal matrix right here. It's going to look like a diagonal identity matrix, and then the answers are going to show up here. 3, 2, 1. And since this was I1, what this says is an equation. It says I1 is equal to 3, I2 is equal to 2, and I3 is equal to 1. And they're all amps. And that should be what we got before. So how do you do this? Anyone have any questions so far? Do you remember doing reduced row echelon form? Maybe not. If you want to do this in a TI, we'll say TI-83. Which one do you guys have that's most common? So I'm sure all these things will tell you, but I'm sure one of these will tell you as well. You basically need to put the matrix in by going into here. You push second. Somewhere on your calculator, you're going to have something that says matrix. Okay? So if you have one of those calculators, you can do it right now. Second, X inverse is what it's saying, but look around, you're going to have something that says matrix. Once you get into the matrix menu, you need to get to edit, and then you just push enter on the first matrix right here. You then go through entering the matrix, just like we did here. You'll put 3 by 4, and then you'll just go through and you'll type in all the numbers here, like something like this. Okay. You then quit the matrix screen, and you go back to the matrix menu by doing the same thing. But this time you go to the math part, and you scroll down here until you see the letters R, R, E, F. You then push enter. It brings you back to the home screen, and it says RREF. That stands for Reduced Row Echelon Form. And then here you're going to put the matrix that you created. In this case, the matrix was called A. So you select the matrix A, you push enter again, and it spits out your answer. It's exactly what I did here, except like what I did a second ago is going to be a little bit easier. You just go to the website. But you can definitely do it on your calculator. Did that make sense? Do y'all want to have a chance to try to put it in your calculator and make sure you can actually get it right? That's normally what we would do, and then I would hand out TIs in the classroom too to like let people learn how to do this. But definitely simplifies these problems a lot. It saves you from having to do the algebra where you can very, very easily make an algebra error, which I did. I made an algebra error there too, I think, right? I made some arithmetic errors. That's what I did. This can save you a little bit. If you have a problem getting this to work, you can just let me know. You wonder if some professors make their students do this by hand. Yeah, sure, I'm sure they do. I don't really see the value in that. But I personally kind of like doing it by hand. It's kind of fun. You know, you do things like you say, if I take equation 2 plus equation 3, you can basically, you add the rows, and it takes a bunch of steps. Like to reduce this one down, it'd probably take, but the goal is basically you just want to get it into this form, and you do so by like, you know, you kind of follow rules where it's like, I'm going to take equation 2, I'm going to add it to equation 3, that eliminates these two, and then you do something like, you just do some things. It's kind of fun. All right, so does anyone have any questions before we move on? All right. So what we'll do now is we'll just look at another one of these, but it's going to be a little more complicated one. I believe so. I have 2 here. I guess we'll do this one first, and then I'll have. Well, I'm going to have all of you do these. I'm not going to do them. I'll do them after you've had some time to work on them. But let's do this one first, because this one's really similar to the one we just did, and then this one's just a little more complex because it adds in more unknowns. All right, this one comes from your textbook. I think I assigned this as a homework problem too, so you'll get a little step up on your homework by solving this one. Okay. I think we'll just do 26.28. Yeah, the other one just involves just changing one thing. All right, so that's the picture. You've got a similar circuit to the one we just did. You've got your batteries. You've got your resistors. It says, in the circuit shown, find the current in each branch and the potential difference VAB of point A relative to point B. So focus on just solving part A, and then we can discuss how you do part B. I could tell you, really what you do is you just do a loop rule, but you stop at A. And you either do it from A to B in one way or the other. So try to do this one here. You want to redraw it for yourself. You want to draw your own picture. You also want to draw in your loops of how you're going to do the loop rule. And most importantly, you need to label currents. Right? Call them like I1, I2, I3. All right? give it a shot. I'll give you... I don't know what kind of time it's going to take to do this, so I'm just going to give you 5 minutes, and at 7:41 I'll just ask to see where you're at. Yep, you got it, dude. I'll grab that real quick. There's your conventions. Should really write that down in your own way somewhere, probably. Or how do you know where you need to label the eyes? You mean whether you label it left or right? There's 3 different segments. There's going to be 3 different currents. Does that answer your question? What you label them is up to you. What direction you choose is up to you.
Okay, that was 5 minutes. It's not very much time. Was that enough time for y'all to at least write down the equations? That's really all I wanted to see, if you could just write down the equations. No? You need more time? Okay. Please take more time. You can. The two inner loops. It's up to you, Mr. Meowers. You can either do inner and outer, or you can do inner. Doesn't matter. Just pick 2 loops, whichever ones you want. Make sure it's a closed loop. Okay, how about now? Are people getting equations down for the loops and the junctions? Is that enough time?
Don't worry about solving them. We'll just solve them with the calculator. Is that enough time? Oh yeah, so this is where we're all going to have to start to agree on. Our equations are all going to be a little different in this case now, right? Because it's going to depend on how you labeled your currents. Yeah. All right, let's talk about this.
So first thing I'm going to do here is I'm just going to redraw a picture here. You know, do so in a way that you got some answers, right? Okay. All right, so let's simplify this down. First thing I'm going to say is that because you have a 2 ohm here and a 3 ohm here, they're technically in series with each other. So that really is just a 5 ohm resistor. So we're going to have a 5 ohm resistor right here connected to our battery. The battery is arranged so that this is plus, this is minus. You do not need to make the simplification that I just made, but it does simplify things a little bit. Next, we've got the middle piece right here where you've got a 4 ohm and you've got a 1 ohm. So I'm going to simplify that by 4 plus 1 is 5 as well. The EMF here was 10, right? So 10 volts. And then we've got this is 5 volts. And then the outer piece right here, we've got 10 ohms. Okay, Ash, you asked, can I purposely do a weird one to illustrate that it always works? What do you mean exactly? How did y'all label your currents? Did you go I1 in the top, and then I2, and then I3 like the last one? Okay, good. So I'm going to choose to make mine like this. I'm going to say this is going to be I1. This is going to be I2. And then this will be my I3. Sorry, with capacitors, I thought you couldn't go across a battery, but with resistors, is that fine? What do you mean couldn't go across a battery with capacitors? I don't know what that means. Alright, so... Ooh, whoops, that's not what I meant to do. So, we're going to use this junction right here. There's, once again, there are 2 junctions, one here and one here. At this node, all 3 currents are flowing into it. So I'm going to say that my junction rule is going to be I1 plus I2 plus I3 is equal to 0, which means one of these must be negative. That's my junction rule. For the loop rule, we'll do something similar to what we did last time. We'll go... let's start from here, and we'll go in a loop like this. That'll be loop 1, and then we'll do a loop like this, and that'll be loop 2. We'll start here. If we start at this point, then we go across the battery right here. You should get positive 10 volts. This is going to be for loop 1. 10 volts. We're going in the same direction as the current, so you get minus 5I1. We loop around to here. Now we're going against the current, so that makes us plus 5I2. And then negative 5 volts here. For our second loop, we're going like this. Let's start at this point for our second loop. So we go across here, we immediately encounter a 5-volt battery. We're going from negative to positive, so that's going to be positive 5. We're going in the same direction as the current, so we get negative 5I2. Keep going around like this. We're going opposite the direction of I3, so we're going to get plus 10I3. Okay. Let's see, so 10I3 plus 5I2 equals 5 volts. And you got so I guess looking at your equations, Tyler, we appear to have similar equations. And I don't know what direction you picked I3, but they look pretty similar, so probably right. Does anyone have any questions about those? The other possible loop would have been all the way around the outside that we could have done. Yeah, that makes sense. Your directions are different, yeah. you combine resistors on different sides of a battery. Could I have done that with capacitors? Yeah, maybe you're right. Maybe you can't do that with capacitors. That's right, Ash. Yeah. Would you have gotten the same thing if you choose to not combine the resistors? Yeah, absolutely. Because if we hadn't combined the resistors, suppose we did the exact same thing here. So we'll start from this point. I'll show you what we would get. Since we're calling this I1, what we would have gotten is, what is it? Negative 3I1. Starting from here, negative 3I1. And then we would end plus 10. And negative 2I1. And then coming around here, we'd have, the I2 goes this way. So you'd have plus 1I2. And then plus 4I2. Oh, I skipped one. And then the 5 volts here, minus 5 volts. But that becomes the same equation, right? Because it's negative 3I1 and negative 2I1, so negative 5I1 shows up right there. And negative, or is it positive I2 and 4I2, it shows up right there. So you would have gotten the exact same thing. It's because it's the same branch, and they have the same current flowing through them, Tyler? Yeah. But you end up getting the same equation as me, regardless, right? Okay, next step is to rearrange these equations so that they look like the ones we did before. So this one here is going to become negative 5I1 plus 5I2. There's no I3s that show up here, so we'll put plus 0I3. This is wrong. There's no way that I3 actually goes this way. I agree. Totally agree with you on that. So we're gonna what's gonna happen at the end of this is our answer for I3 is gonna end up being negative. Okay, but I'm free to draw this any way I want to begin with. I don't want you to sit around thinking about, oh, should I draw it left, should I draw it right, because it doesn't matter. You can draw it either way. Does that answer your question, Juan?
You just pick on the diagram, and then the numbers kind of work out in the end. Yeah. Okay. Cool.
All right. So then negative 5I1 plus 5I2, 0I3. We have 10 minus 5, so that's going to be negative 5 when we move over here. This equation, we get 0I1 minus 5I2 plus 10I3, also equal to negative 5 volts. And then we've got this equation's done. It's already good, right? Can I re-explain why I1 plus I2, I3 equals 0? All of the things are going into the same junction. And the way that I said you need to do this is you want to define, where's the junction rule? Junction rule right here. Oh, up here. Define current as positive coming into the junction, negative when it comes out. So if we had done the other junction, they would have all been negative. Because from this junction, they're all leaving the junction. Okay. We want to make a matrix right here, right? So let's go ahead and make a matrix. We'll start from right here. This one is an equation that is 1, 1, 1, 0. This equation is negative 5, 5, 0, negative 5. This equation is 0, negative 5, 10, negative 5. And if we RREF this, if you want to put it into your calculator, go for it. I'm going to put it into this...
That's the one we used. So we got... we got to do more rows here. 3 by 4. Alright, there we go. 1, 1, 1, 0. Negative 5, 5, 0, negative 5, oops, and then 0, negative 5, 10, negative 5. And those are the answers. 0.8, 0.2, and 0.6.
So we end up getting I1 is 0.8, negative 0.2, and negative 0.6. I think that's what it said. I'll tap back. You should also be able to verify this.
By doing it by hand. Is that right? Oops. There it is. 0.8, negative 0.2, and negative 0.6. Okay.
And that's it. Do a messy algebra, just gotta write the equations down, create a matrix, do RREF, reduce for echelon form. Anyone have any equations? Does anyone have any questions?
Okay, so we want to do another one next that's a little harder. So the last one that we'll look at before we start talking about capacitors and resistors together will be this one. Before we move on, I just want to make sure, any questions at all about this one, or does this feel okay? You do enough of these, they're really easy. You're just following rules. Just following rules. Remember, the procedure is you label your currents. You don't care what direction you pick, because if you pick the wrong direction, you'll just get a negative sign. So those of you that pick different directions, you probably got different answers, but they should sync up with mine. Harder than you originally thought. I mean, it's a little tricky, but it's just, you just got to get used to drawing it and doing it, and you know, using these rules, and you'll be fine. Oh, there's another piece of this question that we should actually address too. The other piece was to find the potential difference of point A relative to point B. So to do that, what we're going to do is we're going to do a loop where we basically go from B to A, okay? And we'll do it on this diagram. This is where we have to have them not combined anymore. The simplest loop that I can see, it's not a full loop actually. We're going to go this way, and then this way. And we'll use the numbers that we have in our problem. So our numbers were that the I1 right here was 0.8 amps up here, and the other one was I2, and you got negative 0.2 amps flowing in this piece right here. So what we're going to do is, we were going from B to A, right? So from B to A, what we get would be 4 times 0.2, but because the direction we chose for I2 was, that's the path, right? The direction we chose for I2, the current, I went this way here, and the current that we chose up here went this way. I don't know if you can even see that arrow. There we go. So going against the grain for I2 here means we add. So we're going to have positive 0.2 amps multiplied by the resistor, which is 4 ohms. And then we get to this piece right here. We're going downstream. So then we're going to do minus 3 ohms times 0.8 amps. And this should give us the potential of point A relative to B. So 0.2 times 4 is what? So it's like 0.8 plus or minus 3 times 8 is 24. So this is 0.8 minus 2.4. I think it's negative 1.6. Does that look right? Does that math check out? Okay. All right, that's the other half. So what I'd like to do now then is we're going to look at this last problem. I think I already moved it down, didn't I? So this is the problem we want to look at. It's a little more complex because you've got four segments, and you've got, well, how many junctions do y'all see in this picture?
How many junctions do you see there?
There's 4, right? No. You can't use all of them, but you can use 2. And then you're going to need 3 loops. Can't use 4 loops because if we used 4 loops, they'd become degenerate. there are a lot of loops here. There's a loop around this one, this one, this one. There's also a loop that contains these two. There's a loop that contains these two. And there's a loop that contains the outer ones. There's a total of 6 loops. So 6 loops and 4 junctions, but you only have 4 unknowns. There's a possibility of 10 equations that you could write out of this. Don't let that overwhelm you. You just need to pick 4. Okay, so pick 3 loops and pick 2 junctions. Label currents. Should we maybe pick some currents right now so that everybody has the same currents in their picture? I don't know if I like that very much because it implies to some extent that, you know, but yeah, it will make it clearer. Like, all right, so let's do this. Let's go left to right. We'll go, we'll call the one out here I1. We'll call this one. We're gonna make them all go the same direction just to be simple. We'll call this one I3. We'll call this one I4. And just as a hint to the way this problem works, we're going to call this one right here I5. And what I would encourage you to do is to use these 2 junctions right here and here. Okay? Oh yeah, you want me to bring down the loop rule again? Sure, no problem. Or just that you just mean the conventions, right? Yeah. No problem. Okay, so there's that. We're taking a break now too, so we'll take a break till 15 after. You can spend however long you want to spend on this, and when we come back, I might give you a little more time too. So I'm going to stop the recording.